In this video, I'm just going to be going through a bit of normalization. I want to use the 2016 past test as an example of it. And this is the idea of selling a bike, selling motorbikes and keeping track of the sales of the motorbikes. And I gave a couple of tables as an example. So the one was your bike for sale, and then the sales of it. And I gave the information here. Now, if we see here, what can you tell me already that there's a composite key? What is a composite key? Means that it's a primary key, a unique identifier that is made up of more than one field. So we've got that. Now, when you at the get-go or at the start, when you are trying to design something for your system, if we wanted to do a bike sales, you would look at what you needed to store. Now, we would identify there would be a bike that you would need to sell, right? And there would be, you would want to physically keep track of the sale, and you would probably want to keep track of the client. Do you get that? Now, you would probably also get make models and those kind of things. So that's kind of what we would assume if we were creating the system. Does that make sense? Now, what you will actually end up with is an access database. Now, when you're creating an access database, and I'm doing this on your guys' M2018 shared, so you will have access to this when offline. But when you're creating it, we're going to create a bike sales database. Now, you'd always start by creating a database. It must exist before you work on it. It's not like a Word document where you can start working on it before it exists. The reason why is because you never actually take ownership. You never have a copy in RAM. You're always just looking at it, and then whenever you change something, you actually are just sending instructions to the server. So your database file must exist before you actually do anything. So now when I open up the database file and I enable the content of it, this is just saying that it's trusting security settings, and you can create tables to store data. So we know we're going to create, I'm just going to create 3 tables at the moment. The first one I'm going to call, the reason why is that it's got no data in here. So let's just, so we're going to have the one bike table, and we're going to have another table called, so create table design, and we're going to call this one, I'm just going to create another one. This is for client ID, let's just say, and you would set that to be an auto number, meaning it will automatically generate, so you give it a data type and primary key. This we'll then save as our client, and then we would have close. We would have another table called, this would be our sales table, so sales ID, also order number and primary key. And order number will be often a way that you would create your primary key, because it means the server is then responsible for creating a unique identifier. And this is why we have ID numbers. This is why we have, because we can't, it's very difficult to control unique identifiers unless you have a system that will ensure that that's uniquely identified. So now I'm going to save this as, what was this? This is actually sales. So now we've got those 3 tables. But now we actually want to design these tables so when we input data, so if you look at this example here, they've shown us the bike for sale database and a TBL sale database. And they gave us example data here. Now you see Craig Bacon has to be entered, and his information has to be entered twice. And this is an example of redundant data, and so with Car and Ham. Car and Ham's information had to be entered twice, and so does Craig Bacon. Now, also, if the same vehicle had to be sold again, in other words, we sold it to someone, then 5 years down the line, we got it back sold to us, and we sold that motorbike again, we would also have to reintroduce that bike into our system. Does that make sense? So actually what we would want to do, and if we look at this and TBL sales, we would say we would want to use this information. And again, you'll notice there that it's going to be very tricky for me. If I asked you right now, please get me the bike sold by Ben Pizza for $32,000, it's going to be very tricky to separate his bike or his sale away from the second sale that he did, because he sold 2 vehicles. Do you see that? He sold 2 bikes. Ben Pizza sold 2 bikes, a CJ229 and a FPJ32 whatever. That's made life very tricky, hasn't it? Do you guys get this? Because it's all inside there. So now we know that this design is stupid. So what we have to do is we have to come up with a design that would implement it better. Now, in a test, you would get asked questions about rules and so forth, and I'm not going to do that. I'm not going to go through the rules and whatnot. You guys can learn the rules. I've given you the stuff on there, and I might mention some of them as we go along. But I'm just wanting to take a look at the design of this. and go through the basic concepts that we're looking at. Firstly, full name, seller ID, and seller ID. That's kind of got to do with the seller, doesn't it? Who is selling the bike. Now, here, this customer, what has this got to do with? This has got to do with more of a purchaser, doesn't it? I'll get your question. Okay, we can take a look at this and identify. In our design, do you agree with me that the seller and the purchaser potentially could be identified as clients? So you would have a client who is selling the bike, and you have another client who is, both of them are clients. Would you kind of agree with me on that?
Yeah, but then yeah, you're still gonna have to make two different classes.
No. I'll get to it now. You will have multiple different tables. So, okay, so we've identified in this table that we need to have a client. We need to have a, what else? We need to have a physical bike. We need to have a sale, and yeah, that's pretty much it. That's what we need. Because if you look at this, a client, for example, in this data, let me create it quickly. So on my bike side of the coin, we know when we design our bike, we need a unique identifier. In this case, for a motorbike, what is the unique identifier for the motorbike?
License plate, serial number.
The registration number. So the registration of a bike will be unique because that's a unique identifier giving it to by the government. Technically, it's the VIN number, which is the unique engine number. That would be there, but quite frankly, we're not going to do that. And this will be a, sorry, not a long integer. This will be a long, where's it now? Number, and it'll be a long integer. So now that we've done this, we'll save that value there. Registration number could be that. What else would we want to store on a motorbike? Make. What else? Model. What else? Year.
Price.
Now, this is interesting. I'm glad it came up with this. It says that it's a reserved word. The word year is actually refers to the date year, so we would say there.
Model year.
Production year.
Yeah, production year, or technically, yeah. Okay, production year, and this would be an integer, a number. We can actually even make it shorter than a long decimal. We can change the size of it so it can be an integer, which means it's much shorter. So you don't need to store a long integer and have this massive number for a product production year. And I would suggest we would also want to have engine size. You might want to also have, so you need to look at what, as far as you look at it as a unique identity. A motorbike is the unique identity there. And you would look at that and you would say, okay, what do I want to know about it? So I want to know the engine size, I'd want to know the production year, you'd want to know the ODO. What's ODO?
Obvious mileage.
It's the total mileage. It's the odometer. The odometer is the thing that will start at 0 on the date of production, and it will never be reset unless it goes over its 999,999 kilometers. But in which case, you'll hopefully notice that it's been a bit like that. Okay, so now this is the information we would store on a motorbike. So if we had a motorbike with the registration number of, sadly, the registration number I am going to have to change into being short text because it is actually a text field. So my registration number is, let's say, WNS 207 GP, which ironically was my old motorbike, and this was a Honda CBR production year 2006. Engine size 1,000. ODO was, when I sold it, it was on 55,000. Okay.
But yeah,
You're stuck in 2006 when shows ready in 3000.
Alright, so now what you'll see is this would be a bike information. Do you guys get that? Now, my clients, what information would I have on the clients?
Bike and like
how much money he has in his bank account?
Number of children.
Okay, firstly, it's most likely we would have the first name, we would have a surname,
Contact.
we would have a contact number,
Is he married?
why,
I don't know.
gender maybe.
If he's
Now,
married, you can kidnap his wife. But if he
what you could do
What is his gender?
is you can set something up to be a yes/no field. Now, true female. So you'd say there, if it's a yes ticked, it would be female. If it's a no, because then it's storing it as a very small data type. So a yes/no field is 1 and 0. So you store it at the minimum data size for that. But you can see you have different data types, and you have to be aware of that because you can store things with different data types and you'll deal with them differently. Are you happy that this would be enough for us to keep track of our clients?
Yeah.
I mean, we might also want their ID or passport number. And technically that could be a unique identifying field as well, but for now, just for sake of simplicity, I'm not going to do that, okay? But now, in there, I'm going to say client ID, first name, because I'm one of the sellers, contact number. I suppose I shouldn't, if I'm going to put this on YouTube, I shouldn't actually put my contact number on there. Okay, and then gender, I'm male, my ID number. Now, and then let's say Frank, Peter Herbert. Peter Herbert, cell phone number 0. Okay, whatever. And his number is okay. Now, now those clients are there, but now we want to work with our sales. Now, on our sales, we are going to create our sales table. Now, if I go into the design, yes, we're going to have to use unique identifier, so we'll have an automatically generated for the sale ID, but we would want to know who the seller was. So now, seller FK means I'm going to be referring to a client who is selling the bike. So it's a foreign key referring to the client that is selling the bike, yes.
The seller isn't a table.
No, it's not, but client is. Because a client can be a person who's selling the bike through us, and a client is also the person who's buying the bike through us.
You have to say client FK then, not seller.
No, put it this way, in my description I can say here, and I could say refers to the client selling the bike from table client. Okay? And then here, I would also then have a purchaser FK, and this would also be refers to the client buying the bike from table client. Now, you could argue, and this is when you, as the programmer, as a system designer, will make up your mind. You'll decide, would I actually want to have a for sale table? In other words, when a client comes to me and says, I want to sell this bike, I would take a record of it then, what his asking price is. And then I'd have a second table where the physical person has purchased a bike. Does that make sense? So I'd have a table to list, and I'm actually going to do that. So I'm going to have a for sale table. So I'm going to close this table. I'm not going to save it. I'm going to call this a for sale table. In other words, the person who wants to sell their bike through us, because we are one of these car or motorbike sales people on the side of the road, a person is going to come there and say, I want to sell my bike. Can you put it on show for me? Sure, we charge 10% interest. Does that make sense? So no matter whatever we sell it for, we take 10% of that cost. Do you get that? Now, when a client comes in and puts the bike for sale, we'll go, okay, we are now going to take record of that you're selling it, and the asking price that you're asking for is this much. Does that make sense? We are then going to actually have we're going to have another table called sale. So we go to our table design, and this is what you do as a system analyst. You look at the system, what do I need to achieve, what do I need to store? So when a client comes into my shop to sell his bike, I need to keep a record that I'm going to keep this bike on my showroom floor, and then only when someone purchases it will it be removed from my showroom floor. And doesn't technically get removed from my table. I could just do queries to determine that it has been sold or has not been sold yet. Does that make sense? So what you could also do, we'll go back to that. But here I'd have my sale ID, and this would be an automatic number, and it would be a primary key. I'll then have the client FK who is selling the bike, who is purchasing the bike, purchaser of the bike. I'll then have the bike Okay.
this is the for sale class.
No, it's not. This is the, let me say this table, this is the sold. This is the physical sale. So here they put it on for sale, here they put this on for sale, and then there they actually sell it. I'm sorry, this is getting a little complicated, but so here I am putting the bike, I come and I say the bike is for sale. So we're going to have client FK as being a foreign key refers to client who put his / her bike for sale through our company. Then you would also have their bike FK, which would refer to the bike that is for sale. And then you would have asking price, and this would be currency data type, and this would be amount asking for. Does that make sense? So I'm creating this table now. So let's say I want to show you something that is actually computer-aided technology, which is a CAT thing. You guys don't do this because you would actually create the code behind this, but it would make me showing you this a little easier. In Access, you can create what's called a Lookup Wizard, where I will look up the value from the table client. I would look up the ID and the first name, and I would hide. For our sake, I'm not going to hide the key column because the client ID is going to be stored. The number 1 is going to be stored, not Craig. The number 2 is going to be stored, not Peter. Does that make sense? So the first column is what is being stored. I'm just showing the second one for the ease of use. Now, I want to do the same thing for my bike FK. And you'll see it changes it to a number because I'm not referring to client Craig. I'm referring to client 1. That is what is being referred to. Does that make sense? Same thing here. When I go for sale, or the sale class, sorry, the next one is the bike FK. I'm going to go Lookup Wizard, and I'm going to look it up from table bike, and I'm going to look up the registration number, which is the primary key. Because remember, when you're creating a relationship, you're creating a relationship between a field and the primary key field in another table. So I'm creating a relationship between bike FK and registration number. I can then display the make and the model if I want, just so that we can have a bit more to see, but the registration number will be what is stored. Next, now this is all Access stuff. This is not the fundamentals of databasing. You guys may understand the back end of databasing. Here I'm just creating the logical concept of relationships. Yes?
What are we going to use for our databases?
You will use Access to create them, but you'll communicate from Java to actually work with them. So you'll create them in Access, but you will use Java to create platforms to communicate with the database, not Access, which we're doing here. And then in my sale table, my client FK, same thing as my client FK would look up from which table? CVL client. It would look up the client ID field, which is the primary key field, and it would display a first name just for ease of use. We won't hide the reference, so we can show you that's happening. And for sale FK means which. This here is looking up from the for sale table, and it is going to ask sales ID, client FK, bike FK. Next, next. We don't want to hide key column. There's no data in there yet. That's why it's showing us like that. Finish. Yes. Now, I'm going to populate this so you can see what's happening. Now, in our for sale, in our sale price, we would actually have an actual amount. And this will be a currency. Refers to client FK and refers to for sale. Now, when I've created these tables, I'm going to save all of them. And I'm going to close all of them quickly. Close all. And I'm going to show you something here. I'm going to go database tools and I'm going to go relationships. And what you'll notice is that let's just try to lay it out nicely. Okay, my client is my bike is related to for sale. So when I put a bike for sale, bike FK refers to the bike that's for sale here. Does that make sense? So this bike has been put for sale. So whatever make I've said that is for sale is put over there. And my sale over here is referring to this, this for sale got sold for this amount. And this client shows me, one, which client is buying the bike and which client is trying to sell the bike. Because both of them are the same entity. A client is a client. The person who's selling the bike is a client to me. The person who's buying the bike is a client to me. They make zero difference. But literally, I'll refer to them in the for sale because that client is putting this bike for sale. I'll refer to them as sale, and that client is putting it. I'm just going to pause the video. Or is this a good question?
Yeah.
Yeah.
Like I feel like it would just be easier if we separate the client class into two ones with like seller and buyer.
You could, but to me, you might have data redundancy later, where the person now who bought the bike is now selling it to you again.
No, but then you just put them on the other table as well.
Yes, data redundancy. You have to enter the same person's information twice. Wow. My name is Craig Bradley. I am on a record with the government. When I go and I buy a house, I go and my data from my ID information gets taken and referred to. Why? Now when I go buy a car and I need to register it with the municipality, that the fact that I've got a car, do I need to now create another entry of me as a person?
Well, like what you can do is you can use the client class and then you just make like
Continue on this. Now I'm going to go to the other view of the tables now, and I'm going to go to my bike. We've already got a bike located, and we've got two clients. I'm happy with it. Now let's say, now you check here. I can say I put my Honda for sale at an asking price of 45,000 Rand. It was a code 3, that's why. Anyway, then, so you see that bike is for sale. Do you guys get it? So I have now gone and I have put this bike for sale. Now, when there's actually a physical sale, so Mr. Peter comes in and he wants to buy this bike, or that specific entry that this bike has been put for sale for this much, and he offered 42,000, and he spoke to the clients and so forth, and he accepted 42,000. So now that bike has been put for sale and has been purchased. Does that make sense?
No.
Now, now here, when I look at this right now, it just says there 42,000. WTF?
That's swing.
It stands for Frankfurters. Why the Frankfurter? Now, when does this information for me as a user make sense? No. 42,000. Yes. But I do know that for sale 1 is referring to this for sale, and this client is referring to that, and this is when we create the front end, which we store like this, so it stores minimally and minimalistic, but we know that client FK2 refers to Peter. So because of that link, we are storing minimal data, so we don't have to use up a lot of data storage, but our front end would create that connection and put that through to there. So now we have designed a database that will be able to keep track of our bike sales. We have created a system that can sell motorbikes. Do you get it? Now, on a normalization test, this is the memo for the test, you'll be asked specific questions. One of the questions you'll be asked is to draw a dependency diagram. Now these are rules that you can keep to make sure your database is normalized. You'll notice that I asked which normal form TBL sales is in. Now TBL sales has repeated groups, so we know it's in no normal form, because the first rule of first normal form means there has to be no repeated groups and there has to be a primary key. So you must look out for things like that. I'm not going to go into this in too much more detail, but did this example help you?
Yeah.
So now I've created, and you can come up with any problem, and your problem you need to identify, for my system to work, what do I need to keep track of? And you need to go and you need to separate everything into its own entities and go through the normalization process and to store data that would make sense for your program. You guys happy? Cool. I want to stop the video. No other questions before I do? Cool. Goodbye.